So we'll now discuss the concept used for notation here. So usually corresponding to the circle x square plus y square equal to r square, we can write the expression x square plus y square minus r square and represent the symbol s. So we can represent this as s. And if it is s1, basically you write x square as x into x, y square as y into y, replace one of the x with x1, other y with y1. So this is s1. Similarly, if I say s2, out of both the x terms, one x is replaced with x2. Similarly, out of y term, one y is replaced with y2. This is called s2. Similarly, if I say s11, we'll substitute x as x1, y as y1. x1 square plus y1 square minus r square. This is the value of s11. And if it is s22 or something, it is x2 square plus y2 square minus r square. And if it is s12, out of the two x terms, one x you replace with x1, the other x with x2. x1, x2 plus y1, y2 minus r square. This is s12. So this is the notation used for this circle. So corresponding to this circle. Like this, we can also write some notation corresponding to the other forms of circles. So this is corresponding to x square plus y square equal to r square. We call it as s equal to 0 in short form. And we can use the notation according to it. Similarly, if I change the circle, for example, if I'm referring to a circle of the form x square plus y square plus 2gx plus 2f5 plus c equal to 0, if I want to write the notation for this, s is the expression without 0. So x square plus y square plus 2gx plus 2f5 plus c would represent s. And what would be s1? Write x square as x into x, replace one x with x1. Write y square as y into y, replace one y with y1. And 2gx is g into x plus x. Because 2x is x plus x, replace one x with x1. 2f5 is f into y plus y, replace one y with y1 plus c. This is s1. Similarly, if you want s2, you can write xx2 plus yy2 plus g into x plus x2 plus f into y plus y2 plus c. So basically, this notation is nothing but a short form which is used instead of writing the full equation. Throughout the chapter, we are going to use the short forms. This is s2. Similarly, if it is s11, you will substitute x as x1, y as y1. So that would represent x1 square plus y1 square plus 2gx1 plus 2f y1 plus c. 2gx1 plus 2f y1 plus c. This is called s11. And if it is s22, then it is x2 square plus y2 square plus 2gx2 plus 2f y2 plus c. This is the meaning of s22. And if it is s12, write x square as x into x, write one x as x1, other x as x2. Like that, y1, y2, g into x1 plus x2 plus f into y1 plus y2 plus c. This is called s12. So this is the notation used for general circle and the circle with center origin. So this also you can refer to as s equal to 0 in short form for this general circle also. And in case you want to write notation for this circle, for example, x minus h whole square plus y minus k whole square equal to r square is the circle. So you can write s as x minus h whole square plus y minus k whole square minus r square. This is called s. And s1 means write x minus h whole square as x minus h into x minus h. Write one x as x1. And similarly, write y minus k into y minus k. Write one of the y terms as y1. That is called s1. Similarly, s2 would be x minus h into x2 minus h plus y minus k into y2 minus k minus r square. This would be s2. And if it is s11, we just have to replace x with x1, y with y1 in the given equation in s value. And similarly, if it is s22, it would be x2 minus h whole square plus y2 minus k whole square minus r square. And finally, if it is s12, write x minus h into x minus h and replace one x with x1, other x with x2. Similarly, the second term y minus k whole square, you write y minus k into y minus k. Replace one of the y with y1, the other with y2 and minus r square. This is called s12. So this is also the notation for the standard circle. So after the notation, we'll now discuss the concept position of a point with respect to a circle. So given a circle and a line for points, given a circle and a point. Now, if I want to decide whether the point is outside the circle or on the circle or inside the circle. So this is center. You join this point. then the point P can also be inside the circle. So to decide whether the point is outside or inside or on, we'll use S11. So first we'll join this and you join this also. So Q is here. So in this case, you clearly see that in this diagram, CP is more than the radius because CQ is the radius. CP is more than the radius. Here CP is equal to the radius. And here CP is less than the radius because radius is CQ here. This is the radius. So for a point to lie outside, CP greater than R. For a point to lie on the circle, CP is R. For a point to lie inside, CP less than R. And if you convert this into the form of S11 notation, let's see what we get. Say P is a given point called X1, Y1 and C is the center of the given circle. So you can take the circle with center origin or different also. So for just convenience, I'll take this circle. But even though I'm doing it for this circle, it is valid for all circles. So center is origin, it's easy to calculate CP. So by distance formula, CP is root of x1 square plus y1 square. This is greater than R. So this will give you x1 square plus y1 square greater than R square or minus R square greater than 0. But according to notation, this is S11. If this is S, so if this is same as S equal to 0, this is nothing but S11. So what is the purpose of writing this notation? Because even if I change the circle and name it as S equal to 0 for other form of circle, this is still valid. That is the reason we are using a general form like S11 and S. And similarly, the same thing here, but equal to is there. So this is S11 equal to 0. And here S11 will be less than 0. So the value of S11 will decide whether a point is outside the circle or on the circle or inside the circle. And how do you get S11? Straight away substitute the coordinates of point in S. You will get S11. If S11 is positive, we say point is outside the circle. If S11 is 0, we say point is on the circle. And if S11 is negative, we say the point is inside the circle. So the next concept we have is position of a line with respect to a circle. So here you can do it in two different ways. The first method is only for circle, but second method will be common with even the remaining conics like parabola, ellipse and all. So given a circle and a line, the first possibility is the line will cut the circle into distinct points. Second possibility is the line will touch the circle. And the third possibility is the line will not intersect the circle at all. So what will be the conditions for this? So if you find the distance from center of circle to the line, suppose you call it as D. In this case, the D will be less than the radius because CA is the radius and clearly hypotenuse will be bigger in the triangle, D less than radius. And here D will be equal to the radius. D will be equal to the radius. And here the distance from center to the line, the D would be more than the radius. So if you find the distance from center of circle to the line that is less than the radius in this case, then the circle will cut the line in 2 points. If it is equal to radius, it will touch the line. If it is greater than radius, it won't cut the line at all. And if they give you the equation of the line and the circle, then you can also write this. That is, for example, if you are given the circle as x square plus y square equal to some r square, and the line as say y equal to mx plus c. So the center is nothing but origin in this case. So what is the distance from origin to this straight line? Mod c by root 1 plus m square. That is your d value. This is less than radius. And here mod c by root of 1 plus m square is equal to the radius. And here mod c by root of 1 plus m square is greater than the radius. But the result which I wrote now is for the circle with center origin. You can even write it for circle with a different center, but this criteria only we have to use in general. And what you wrote below is for a case with circle having center as origin. But otherwise, in general, you can use d less than r, d equal to r, d greater than r. And since you already know how to find distance from a point to a line, with that you can find d value if the center is different also. Like for example, if the circle is something like x minus h whole square plus y minus k whole square equal to r square, and the straight line given is something like ax plus by plus c equal to 0, then what is the distance from center to this line? You just have to substitute the center coordinates in this. Mod of ah plus bk plus c by root of a square plus b square. This is d value, distance from center to this line. And that you'll compare with the radius. Okay. But this is how you find d if the center is not origin. If the center is origin, we already have the result, which you can remember. So instead of this method, what is the other method which is common with the other conic sections? So basically, you can just say that if you are given a circle, it may be a circle without center as origin also, but method is same. But just for simple calculation, I'm taking center origin. Suppose you are given a circle and a line. You just solve both. solve the line and the circle, you will get a quadratic. So what is the quadratic? You get x square plus mx plus c whole square equal to r square. Putting y equal to mx plus c in the first one. Now just expand this x square term here, and here you'll have m square, x square, write them together. You will get x square into 1 plus m square. Then you will get 2 mcx plus c square minus r square equal to 0. Just write it like a quadratic in x. And once you write as a quadratic, we can find the discriminant with the formula b square minus 4ac. So b square would be 2mc whole square minus 4ac means 4 into 1 plus m square into c square minus r square. So this you can simplify by opening the brackets and all. Then what will be the criteria for the line and the circle to cut? The roots of the quadratic are real and distinct, d greater than 0. For the circle to touch the line, the quadratic should have equal roots. And for the circle and line not to intersect, discriminant is less than 0. So when you do this, this will give you c square less than. When you simplify, the greater than will become less than. Because you already know d value. So use this d value. I'm writing the answer directly. So after you open the brackets, actually this m square, c square will cancel. I think you'll get 4 times r square into 1 plus m square minus c square as the value. So when I take this is greater than 0, it will actually reverse and change like this. Here you will get equal to sign. And here when you simplify, the less than will simplify as greater than when you simplify it. It changes like this. So last term is just C only. It's not CK. So by mistake I wrote. So then we have length of chord intercepted by a circle. So given a circle and suppose a line is intercepting a chord AB, you want to find the length of the intercept given the circle equation. So I'll take the circle as x minus h whole square plus y minus k whole square equal to r square. So you know center is hk and radius is r. We want to find out the length of the intercept AB cut off by the circle on this line, whose equation is given to us as some ax plus by plus c equal to 0. So then you just drop a perpendicular like this, and the distance is suppose d. And clearly you can see by Pythagoras theorem, AM will be root of r square minus d square. For triangle AMC, if you apply Pythagoras theorem, AM will be given by this. And the chord AB is 2 times of AM because M will be the midpoint. So it will be 2 root of r square minus d square. And radius will be known from the circle anyway. And how to find distance d? Distance from HK to this, I already discussed earlier. It is mod of AH plus BK plus C by root of A square plus B square. With this formula, you can find the distance from center to the line. You put that value here, you'll be getting the value for the length of the chord. So we now have the formula for chord joining 2 points. So the first one is called the Cartesian form. So given a circle, in short form, let us take it as S equal to 0. So it can be the circle with center origin or HK or general circle. Anything you can name it as S equal to 0. And suppose the chord joins x1, y1 and x2, y2. So for whatever may be the circle given, the formula for chord AB would be S1 plus S2 equal to S12. I already told you how to write S1, S2 and S12 for all the types of circles given the value of S. So we just have to use this formula. A derivation we can skip for this, not required. It's not so important. Then the second form is the parametric form. So you'll be writing the equation of the chord joining 2 points in parametric form when you are given the ends of the circle. So for example, if the circle is x square plus y square equal to r square, what are the parametric coordinates of A and B? Some r cos alpha, r sin alpha, where alpha is a parameter, and B would be r cos beta, r sin beta. Then to find the formula for chord joining A and B, we have to just apply 2-point form. I'll give the direct result. It will be x cos alpha plus beta by 2 plus y sin alpha plus beta by 2 equal to r cos alpha minus beta by 2. So this derivation you can skip again. So when you apply 2-point form for A and B and simplify using some trigonometry transformation formulas, you get this as the answer. You need to remember this. This is the formula for chord joining 2 points for this circle. So if I change the circle and give it as x minus h whole square plus y minus k whole square equal to r square, if you have to write parametric coordinates for any point on this circle, you just need to add hk to the previous coordinates. H plus r cos alpha, k plus r sin alpha. And the point B is h plus r cos beta, k plus r sin beta. So then when you write the chord also, you change x as x minus h, y as y minus k. So just in that formula, change x as x minus h, y as y minus k. That will give you parametric equation of chord for this circle. And in case they give you the circle as x square plus y square plus 2gx plus 2fy plus c equal to 0, the parametric coordinates for any point on this would be given by minus g plus r cos alpha minus f plus r sin alpha minus g plus r cos beta comma minus f plus r sin beta. This is AB. So when you write the chord equation also, just you need to change h as minus g, k as minus f here. So it would become x plus g cos alpha plus beta by 2 plus y plus f sin alpha plus beta by 2 equal to r cos alpha minus beta by 2. And how do you find the radius of the circle? For general circle, you know r is root of g square plus f square minus c. We can find it and substitute here. So this is the formula for chord joining 2 points in parametric form for general circle. So this is for standard circle and this is for circle with center origin. So Cartesian form is not that important, but parametric form is very, very important under the chord joining 2 points concept. So write this.